Hi, we'll talk today about the domain of algebraic expression. In general, an algebraic expression may not be defined for all values of the variable. The domain of an algebraic expression is the set of real numbers that the variable is permitted to have. Let's see some cases. So if we have 1 over x, we all know that this x here should not be 0. So we cannot write 1 over 0. It's not defined. So this x here should not be 0. Okay, let's see another case. So if we have the square root of x, we all know that this x here could not be a negative number. So it will be always greater than or equal to 0. So let's see a next case. So when we have 1 over the square root of x, well, this cannot be 0. And this x here should be greater than or equal to 0. So 1 over the square root of x, this denominator here should be always greater than 0. Let's see an example. So we want to find the domain of this expression here. So as you can notice, we don't have x in denominator, so we don't have any condition to worry about. So the solution or the domain for this expression is R. It's all the real numbers that we can think of. So if we can just represent it in the real line, it's all the numbers. It's all the numbers. Let's see part B. So we want to find the domain for this fraction here. So just see here, we can factor it out. So we can just rewrite it as x over, just remember how you factor this. So we want two numbers, the summation of them is -5 and the multiplication of them is 6. So if you search in numbers, you'll find that these two numbers are nothing but -2 and -3. So this would be x minus 2 multiplied by x minus 3. So we all know that this denominator should not be 0. So here, the domain for this would be this the real line. So this cannot be 2 and this cannot be 3. So here is 2 and here's a 3. This is the domain. It's all the real numbers except the 2 and the 3. Let's see part C. So we have this fraction here and we want to find the domain of it. So the first thing, look here. X cannot be 5 because if x equals to 5, the denominator would equal to 0. So x cannot be 5. And if you look here, we have square root. So x is greater than or equal to 0. So let's see the real line. So this is the real line. Here we have a 0, here's -1, here's +1, and here's +2. So, from this condition, this is the domain. So, it's all the numbers, including the 0. So, it's all the positive numbers. So, and if you look of this condition here, we know that x cannot be 5. So, let's suppose that 5 is here. So it would be an open circuit. It's not included in the domain. So the domain is from 0 until infinity, but 5 is not included. Why it's not included? Because when we have x equals 5, we will have a 0 denominator, which is not defined and not possible in mathematics. This is the end of the video. Don't forget to subscribe, like, and share the video. And goodbye.